Okay, so I hope my PPT is visible. Let me share my PPT. Oh, wait, I think I need to reshare it. Okay, so now we are going to discuss about the security of IoT, because if you remember it, in the last class, I mean most of the previous classes, we somehow talks about the security, right? I hope my voice is audible, right?
Yes, sir.
Okay, okay, fair enough. So in the previous classes, we somehow in every class we talks about the security, right? And why security is required? That is the question. Why security is required? So just suppose the case of an IoT. So as we are aware of that, IoT is rapidly spreading. The application of IoT is rapidly spreading, and each has, as the previous speaker also demonstrate some of the features. So and we are aware of that this IoT is reaching multimodal of different domains. Like this domain may include like personal healthcare, environmental monitoring, home automation, smart mobility, and industry, right? Like I mean there may be many more application which I might not have talked, right? So as we are aware of that, so as we are aware of that the application of IoT is enormous, right? I mean, you as the previous speaker suggested also that in India there are a lot of possibility in IoT for the different field. And what happening as it's the application area is increasing, the number of IoT devices which we are deploying is already increasing, right? And since it is increasing the area, the number of devices are also increasing, and more specifically we are going to have application in public private environment, right? And therefore IoT becomes uh, a common object in everyday life, right? So what we need to do, so if it become a common uh, object to in everyday life, therefore the security threats are also uh, I mean there are also security threats, and these threats may be a leakage of sensible information, right? Denial of service attack, I think most of you are aware of the denial of service attacks, as in the previous class you have also talked about the service attack. Non unauthorized access, right? And the problem with this IoT is mainly low end IoT or the conventional IoT, which is having very less computational power. They are not designed to uh, counter the security threat or the cyber threat. Therefore, it is our to focus us on the security threats, right? Now let me share my slide. Uh, okay, I'll stop the camera. There is no point of camera. Okay. I hope my PDF PPT is visible. Okay, so what we are going to discuss is why IoT security, what are the challenges, and main security mechanism for IoT services, security of popular IoT communication technologies, examples of implementation and commerce in commercial devices, and I will compare that. Okay, so to be very frank, what I'm going to cover is I'm going to cover the basic challenges for the IoT and what are the basic mechanism through which people are trying to attack the IoT systems, right? So I might not be able to cover all those things in the given time, but definitely I'm going to cover what are the basics of that, right? So why IoT security? So as I discuss you, the IoT has large number of application and its implementation is such that it implemented either public as well as the private environment also. The second point is, which is very important, is IoT devices are heterogeneous, right? So one of the person is using different platform for IoT communication. The other person is having using for different communication. So there it also poses a challenge. And third is, which is most uh, important, that the limitation of IoT devices. And how, what is the limitation? Now see, uh, cyber security or the security is not new to not new to us, right? But whatever the security mechanism up till now they have deployed or they have researched, uh, it mainly suited for higher end devices like your laptops, mobiles, right? But the IoT has the limitation in terms of power and in terms of computational capability. So we cannot apply those mechanism. Just see, we cannot apply those mechanism straightforward for the IoT application, right? So we need to have the different mechanism. Therefore, we need to focus on IoT security. As already told you that we cannot adopt the standard security mechanism because we are aware that this mechanism, the conventional one, will not work because of this limitation of low power and low computation complexity of IoT devices. What happened initially when the people are trying to when people are designing the IoT devices, they never thought of the securing these devices. They are only thought of making cheap devices and integrating with the network and solving their purposes, right? So that is why we need to focus on IoT security in much detail, right? Now I'll talk about the challenges. What are the security challenges? So the mostly attack on IoT devices are very simple and very easy to conduct, right? And these attacks are generally used to leak the data. And as I told you, the application of IoT devices are also in the personal environment, so it may leak your personal data as well. So now, what is the common way of attack is what they do? The attacker posts one of the devices, and it is posed like it is an actual device, and it is trying to sneak in your IoT network. So, in order to understand the IoT security, or I'll say rather security, these two terms we need to understand. What are the security requirement and what is the taxonomy of the security attacks? So next we are going to discuss the security requirement, right? So the security requirement are different at different operational level. So uh, first is information level, the second level is access level, and third level is the functional level. Right. So these three levels we need to secure in order to have a secure IoT platform. So security, now I'm discussing the security of information level. So security at the information level must follow the following requirement. The first is the integrity. Integrity means, like, suppose we have a what to say, there is a transmitter and we have a receiver. Right. So whatever the message the transmitter generated must reach to the receiver. This message, let us say it is generated M, and at the receiver end we are receiving M dash. So integrity of message is lost. So what do you mean by the integrity is, whatever the message you have generated, that must reach to that must reach to the receiver end, right? The second point is anonymity. The source of data is known to only intended person. I'll give you the example for that also. So what do you mean by anonymity? Just see, like there is one transmitter and there is one receiver. Right. And let us say we have two transmitter to a better understanding. Let us say we have two transmitter 1, transmitter 2. So both are generating the data and sending to the receiver. Right. Now, when there is a attacker in between, so it must not be able to identify by seeing only the data or the message, such that who has generated this message. It must be only known to this receiver, the intended receiver. So this receiver can only be able to identify who have generated the message. Right. So this is the third and very important requirement, that is anonymity. Next, okay. Next we are going to talk is confidentiality. I hope I'm audible. Okay. Okay. Sorry.
Yes, sir.
Sorry for the interruption. Okay, thank you. That means if third party is by anyhow is able to access your message, it must not be able to either decode it or read it. Okay, there is no problem if it is able to access your message. Therefore, the transmitter and the receiver must establish a trustworthy relation. And more importantly, the replicated message must be able to recognize. Right. So we also talk about the replay attack. There, this thing play a crucial role. The fourth important parameter is the privacy. So what happens when you are exchanging your data to the different server? Your private information must not be leaked to the third party or it must not be exchanged, right? If there is any eavesdropper which is listening your network, must not be able to identify your data. So these are the four important parameters at the information level which we require to have for our secure IoT system. Now I'll talk about the access level requirements. So the first is the access control, and it is very much essential. It says that only the legitimate person or the machine is able to control that network, and it is very much required because suppose a attacker is got access control, then it can add or delete any number of devices. Uh, it can route your data to other server. So that will challenge, I mean, that will pose a huge problem. The next point is authentication. So what happened? Authentication, that means only authentic nodes are able to join that particular network, right? So when a node wants to join a particular network, what it does, it contact the coordinator, as we have discussed in Zigbee or many most of the IoT communication technique. So it will contact those coordinator, and after that we will the coordinator will verify the authenticity of that particular node, and once this node is authentic, it will allow to join that particular network, right? Authorization. uh, Authorization mean only authorized devices uh, or the users will get access to the network or the resources. That means there may be blacklisting also. Some devices might have been blacklisted due to the fact that in the uh, uh, history they might have uh, initiated an attack. So there must be an authorization to join that network. Now I'll talk about the Security Requirement Act information level. Resilience, it is one of the required thing which you must have in your network or IoT platform. So what happened if, okay, both the previous things we have talked about, a requirement at the network level or the access level, and requirement at the information level. Those are the methods those are the requirement we must have to secure our IoT platform, right? But what happens at the functional level? We must be so resilient such that if in case of any attack, the network itself is able to secure its devices. And the second is most important is the self-organization. And it says that if a attack is already happened on a particular network or a particular platform, uh, therefore all those functionality of those network cannot be damaged. Some parts of the system can adjust to maintain the operation, and later we can rectify that attack and we can make whole the system operation, right? So up till now what we have done, we have talked about the three levels of security requirement. One is at the information level, one is at the access level, and one is at the functional level. And if our system meet all these three requirements, we can proceed we can proceed for a secure IoT platform or IoT network. I'll rather say IoT platform. Right. So these are the requirements. Now we will see what are the taxonomy of the security attacks. So what happened? We are considering three levels or the three layers. First is the edge layer, right? Second is the access layer or the middleware layer, and third is the application layer. As you have seen in the previous case or the previous lecture also, nearly the speaker talks about these three layers. And if you remember my first class where we talk about the working of the IoT, there we had that edge, there we have the gateway, and there we have the cloud. Right. So for the sake of completeness, you just consider these three layers, right? Now we will talk about or we will discuss each layer one by one. Okay. Apart from these layers, the IoT devices are also used for the some of these functionality or some of these attack functionality, such that ignoring the some of the functionality, reducing the functionality of a particular device, misusing the functionality and extending the functionality. We will see each and every term in detail. So now we are going to discuss the edge layer. So the main attack at the edge layer is side channel attack. Okay. I hope that most of you are aware of side channel attack. Okay, no problem. I'll tell you the side channel. What is side channel attack? So side channel attack is that the attacker is present to very near to the edge devices. Like as we are aware of that most of the IoT devices we are going to place in remote location. So if by somehow uh, a attacker is very close to that edge device, and if it is very close to that edge device, it will be able to place a or initiate a side channel attack. And the goal of these attacks is leak the information. And how it leaks the information? It leaks the information by analysis of side signals such as the power consumption. I'll mark it power consumption, electromagnetic emissions, and communication timings. Right. These are the three parameters. Uh, so the attacker will sniff these three parameters or not have a observe on or by observing these three parameters, it will initiate a side channel attack. Right. And among these three parameter, power consumption is the one of the parameter which is generally is a main focus of attackers, right? So what happens? The power consumption of these devices are widely exploited to guess and recover the encryption keys. So what happened? Suppose there is a edge device. I think someone wants to join. Let me. Okay. So suppose there is an edge device and there is an attacker. So what happens? This attacker wants to gather how much power is generated by this edge device for the communication or for the sending the data. Right. And by these power analysis, it will be able to know the encryption method. Right. So once it knows the encryption method, it will able to decode the actual message, because to have the secure communication, we generally have the encryption of data, right? So there are two type of power analysis which is done by the attacker. One is the simple power analysis and another is differential power analysis, right? So these are the two types of power analysis attacker does to guess or to obtain the encryption mechanism, and then once it get the encryption mechanism or encryption key, uh, it will able to decode all your information. So this is one of the attack, right? Now, apart from this edge layer attack, we also have, okay, I think we also have uh, hardware trojans, denial of services attack, and one of the more prominent thing is make resource unavailable. So what happens, as we are aware of, for the most of the communication techniques, the edge device or the IoT node went for sleeping to save its battery power. But what happened, deliberately that attacker wake up that particular node as such that it can drain that battery of that particular node, and it will start a denial of service attack, because once there will be no battery power, the node will be not functional. Next we are going to talk about the access layer attack. Okay, up till this point, if you have any doubt, we can discuss. I hope there is no doubt. Okay, thank you. Next, we are going to discuss the access layer and the application layer attacks. So at the access layer, the main attack is eavesdropping or the sniffing. So what happened, if suppose there is an edge, there is gateway, and there is a cloud. So we have formed a network, or rather than, I'll go very simple, such that there is a coordinator and there are many devices in that network. So attacker will be there, and what it does, it sniff the messages which are generated by this node and sending to the coordinator, right? So this is the one of the main attacks of access layer. Second is the injection of fraudulent packets. So what it does, this attacker does, it will start injecting its own packet to this network, and this coordinator will think that these packets are coming from this node. What happens, sometime it will also do that, it will believe to be as a sync of the data, right? So it will most of the, or it will pose as a coordinator to this in device or in node, such that the this device or this in node will start sending its own data to this attacker. So there are these kind of attacks. Next is the application layer. So in application layer, what we does at the time of training of our model, as the previous speakers talk about how to train your model, right? So at the time of training of your model using machine algorithm, the attacker manipulates the training, and then the whole system will start misbehaving, right? Next what we do, we talk about different functionalities uh, which is exploited by that attacker. So first we'll talk about the ignoring the functionality. So what happened in this kind of attacks? Some specific functionality of IoT devices are ignored. Like suppose your smart home is there, and there are many more functions. So some specific function cannot be operate. You cannot be able to operate that specific function, right? Next one is the reducing the functionality. So it is very similar to ignoring the functionality. So in this, what happens? A attacker tries to limit your application. Like suppose your IoT application is able to send your temperature data, humidity data, and maybe the light data as well. So what it does, it attacks on some of the parameter, and it will block some of the data or some of the functionality of your devices, right? Like your smart TV, refrigerator can be managed. Maybe someone can manage your smart refrigerator, and it will not allow to make you ice, right? Something like that is come into the form of reducing the functionality. The next one is the misusing the functionality, right? Like suppose your smart house is having heating, ventilation, and air condition system, right? So what happened, it will start like suppose there is a cold there, so it will start increasing start decreasing the temperature of that particular place. Or maybe it is a very harsh and humid environment, it will start the heater, something like that it can do to misuse the functionality. The next one is that is the extending the functionality. It is considered to be more dangerous than all those three. What happens? So suppose your devices are whatever the devices you have are some form of the sensors. So the attacker get uh, uh, sensors, or maybe your different other information through attack, and those of attacks or those information can be extended to know where about yourself. Like suppose if you are having a smart system where there is occupancy sensor is there, so once occupancy is there, the light will be on, right? So attacker can if it access the data of occupancy sensor, it will be able to know whether there is a person present in this house or not. One more thing is like your Fitbands. If attacker gets the data of your Fitband, it will be track your position. So these are the four functionality which attacker use to in case of any attack. Now I'll talk about the main security mechanism for IoT services. Okay, so the main security mechanism is encryption, right? So I hope all of us are aware of encryption, right? So what is encryption? So encryption, what happens, in spite of sending directly on your message, you send a ciphertext, and the ciphertext is nothing but we use either to code that message or encrypt that message either by using hash function, or by using MAC, or by using digital signature. And more importantly, in IoT cases, MAC and digital signature are widely used. So we'll see later on what is MAC and what is digital signature. We are going to see in detail. Now, what is the advantage of encryption? The advantage of the encryption is if by any means the eavesdropper is able to access your network, so it will only can see a message is going from here to there, but it will be not able to decode that message. And that is our main, that is our requirement that a third party cannot know what exactly we are sending to the other receiver. That is our main requirement. Okay. Now, up till now, if you have any doubt, please ask. I'll see the chat box, no problem. Okay. PPT. I hope PPT was available. Okay, no problem. So now I'm just asking you if you have any problem up till this point, and then we will start or move forward. Okay, I hope there is no problem. So we'll move. Now we will talk about the encryption. Right? I hope most of you are aware of the encryption, but still I feel if encryption is new for someone, we will definitely going to cover it. So there are two type of encryption mechanism. One is symmetric and one other is asymmetric. So first we'll see symmetric mechanism. So in symmetric mechanism, there is a secret key used to encrypt that message and decrypt the message, and this code is known to the sender as well as receiver. So I'll give you the example. This is a sender and this is a receiver, right? So what happened? Sender wants to send a message M such that this message is not interpreted by third party. So what it does, it has a key, secret key K, which is shared to both of them. So it also know the key K, and the sender as well the receiver is aware of key K. So what it will do, it will encrypt this message with key K and then send a cipher text C, and at the receiver end what it does, it's decode or interpret that ciphertext C using that the same key, and it will be decode that message in. This mechanism is called symmetric encryption. Now we will talk about asymmetric encryption. So what happens in asymmetric encryption? Each endpoint have two keys, right? One is the public key and one is the private key. And private key is one which cannot be known to the third party. Public key may be known to the third party. Okay, so what happened? Suppose I'll explain this. Like in the previous case, we have a sender and we have a receiver. Right. So this receiver has a public key and a private key. Right. Now the sender wants to send a message. Right. So what it will do, let us say the sender wants to send a message M. So what it will do, it will encode or the encrypt this message M by using the public key of this particular receiver. And it will send, after the encoding, it will send the ciphertext. This ciphertext can be only decoded with the private key of intended user, and then it will have the original message. This ciphertext cannot be decoded cannot be decoded by using others private key. Like suppose there is two receiver. So if somehow if this receiver I'll say receiver 1 and receiver 2, so if by somehow it received the same ciphertext, it will not be able to decode that ciphertext, right? So encryption is done here at the sender using the public key of that particular receiver, but the decryption is done by the private key. So there is a slight difference in case of symmetric encryption and asymmetric encryption. Okay, the same thing I I have depicted here. Suppose a transmitter send a message. So those messages will be only decrypted by the intended receiver, right? So let us see. As here it is written that only able to decode the message encrypted by transmitter using the public key of RX1, receiver 1, right? And similarly the same. I think already this part I have already explained. If you have any doubt on this point, please ask me. Okay, no problem. Now we'll talk about the standard encryption mechanism. So there are two processes by which we can do the encryption. First one is the stream cipher and second one is the block cipher. In stream cipher, what we do bit by bit or the byte by bit, and in the block, what we do, we make a block of the sum of the text, and then we do the encryption of that particular block. Okay, these are the blocking or the encryption techniques we generally use. We'll see in detail, no problem. Now we will discuss advanced encryption standard, AES, and most of the system using either your IoT system or your conventional system use AES. So we are going to see AES is much detail. So what happened? AES can be obtained by performing these operations. I'll be explaining this portion in much detail because this is very much essential. Whether you are going to encrypt maybe your IoT devices or maybe your IoT data or maybe your usual data which you generate from your computer, right? So what happened? What is these blocks? The block 1 is called substitution, transition, and linearity. We will see much detail what are these blocks and what happened. Okay, so let me share my whiteboard. Uh, so okay, I'll give you the example of, sorry, I hope this whiteboard is visible. So I'll give you the example of 128 bit AES. So what happens? These bits are in the form of matrix. So let me design a matrix. So let us write B0, B1, B2, B3, B4, B5, B6, B7, sorry, B8, B9, B10, B11, B12, B13, B14, B15. So this is 128 bit data. So the first operation is substitution. Right. So the first operation is substitution. So what we do, we replace these bits by substituting different bit. So to do that, uh, so we'll do the substitution. So substitution will be like, we replace these bits with substituted bits. So it will be S0, S1, S2, S3, S4, S5, S6, S7, S8, S9, S10, S11, S12, S13, S14, and S15. So we have performed the substitution operation. So if you remember, the first block of AES is S, that is substitution. Next operation we are going to perform is transposition. So we'll see what exactly is the transposition. So the transposition is like transposition. So what we will do, we'll transpose the B. So for the first row, we will do not do any transposition. So it will be remain S0, S4, S8, S12. For the second row, we will do one transposition, like this will become S13, S1, S5, S9, right? For the third row, we'll do two transposition. That means this will become S10, this will become S14, next will become, okay, this will go here, this will go here, and this S2 will be coming here, and S6 will be coming here. So then next we'll do the transposition, right? So S2 will be coming here, S6 will be here. So we have done the transposition. For the next row, we will do 3 transposition. So 3 times shift. So this will become S7, S11, S15 and S3. This is known as transposition. Now we have 4 vectors, right? Let us say 1, 2, 3, 4. Next is the linear operation. So what we do in the linear operation, we multiply a particular vector. Let me, okay. Okay, it will be not reduced further, so no problem. So what we will do, we will take one of the column, let us say S0, S13, S10, S7. We have taken, and we will multiply this vector with a matrix by 4 cross 4, and this will give you again a vector of the same dimension, right? This process is called linear operation, right? And let us say okay, for the sake of completeness, I'll write. Let us say this after this we have got B0 dash, B1 dash, B2 dash, B3 dash. The same linear operation we are going to perform on each of the columns, right? And after that, we are going to have a matrix which will be, oh sorry, I'll write in the same pattern. So this will be B0 dash, B1 dash, B2 dash, B3 dash, B4 dash, B5 dash, B6 dash, B7 dash, B8 dash, B9 dash, B10 dash, B11 dash, B12 dash, B13 dash, B14 dash, B15 dash. Now, if you compare, if I'm able to, I'm not able to further reduce it, but if you compare these two bits, you'll be able to see by these meaning of substitution, transposition, and linear operation, we have changed these bits. Now, this is the output of these 3 blocks. First one is substitution, then the transposition, and then the linear operation. Right. Here is a XOR and other is a XOR. So this is the actual data. Okay, I'll show the PPT, no problem. So this is the main component of, or the main body of this AES mechanism. So how data is changed. Now I'll show you I'll show you. Okay, sorry. Okay, so just see. I have talked about what is the operation of these three blocks. Now this is the actual data. So this is having two keys, K0 and K1. So what it does is it first XOR with the actual data, and after this XOR we will get V1. We will perform these three operations. First it's a substitution, then we'll get W1, then we transposition will get Y1, and then we perform the linear operation, right? After the linear operation, in the previous case we have got B0 dash B1 and something like that, and then the second key will take the XOR of the second key, and then we will get this data. And this is one block. This is all is one block. This block will repeat many times. This block will repeat many times to perform an AES encryption. Now, if you have any question on AES encryption, please ask me. Do you have any question? Uh, how N is decided? Okay, not audible. Okay, I hope I'm audible. Okay. Next question is, can we use elliptic curve? Yes, we can use, but the elliptic curve technique require a lot of computational power, so it might not be advisable to use in case of IoT. Next question is, how is N decided? Can you please tell me which N you are talking? Please type. N repetition of that block. I guess yes, yes. N repetition of the block. Okay. So it decided how much secure you want to make your communication technologies, and as you have seen that only one block requires a lot of computational power. So there is also a check on how much computational power available with you. Should I answer your question? Okay. Next question I'll take. Not up to us, it's up to the system, which up to the system. Like mostly there are fixed systems, right? There are fixed n values depending upon your system requirements. But still, if you want to use in IoT, that n cannot you put large, right? Okay. Next question I'll take. AES in symmetric key method. Yes, definitely. AES is symmetric encryption method. Okay, I hope up till now. Okay, let me share my screen again. Now, up till now, we have talked about we can able to encrypt such that uh, if his message is uh, received by any third party, that person will not be able to interpret it, right? But what happened the case if this uh, sender and this is a receiver, right? If sender sends a message M by using ciphertext C and it's sent to the receiver, what is the guarantee that this C has not been changed? What is the guarantee? So to do that, we need to have integrity protection, that the message had not been changed. And if this message has been changed, the receiver must be able to recognize or able to know whether this ciphertext or in rather simple term, I'll call it message, has been changed. So to do that, we need to have an integrity protection. Okay. So what happened? This authentication and the integrity protection can be done by message authentication codes and digital signature and the hash function, but still most of the IoT devices do not use hash function because maybe they are the complexity of those functions. So what we generally use, we use message authentication code. Do not confuse is the MAC address and digital signature. I hope the digital signature most of us are aware of, right? Okay, so these two methods we are going to use for the integrity protection. And integrity protection says that if a message is changed in between, the receiver will be able to identify whether this message has been changed or not. So let us talk about MAC. So we'll talk about message authentication code. So again, the message authentication code is a symmetric mechanism. So the private key is known to both the parties, the sender as well as the receiver. So what happened here? Let us say this is a sender and this is receiver. Right. So in spite of only sending a message, this sending the sender sends a message as well as a tag T, right? So it not only send a message, it sends a message tag pair, right? So how tag is generated? The tag is generated due to the key. So there is a MAC function. There is a MAC function. From that MAC function, the tag is generated, and the input of the MAC function is the message. Now, upon reception of this message M and tag T, the receiver need to verify whether this message has been changed or not. So what it does, it will verify this message using the same shared key. So if the verification function results 1, that means the message is not altered or not changed in between. If it returns 0, that means this message has been altered. right? I'll I'll give you a classic case example of why message authentication codes are required. Suppose you are a customer of any bank, right? And what happened? You have processed one request to transfer 1,000 rupees from your account to a particular account. Right. Now, if this message is received by a particular attacker, what it can change? It can change 1,000 to maybe 10,000. So what bank will see? Bank will see that the customer have initiated a request to transfer 10,000 to a particular bank account. So there is a threat. Therefore, what will do? The bank will verify the message as well as the tag, and if it verify the message and tag, then it will initiate the operation of transferring the money. The things which I've already explained you. These are the three polynomial function Mac uses: gen, Mac, and verify. So gen is a function which used to generate the Mac is takes the input of the message either 0 or 1, and verify is a function which verify the tag as well as the message sent by the sender. Okay. Next one is we'll talk about the digital signature. So digital signature is an asymmetric mechanism. Digital signature, as I told you, is a symmetric mechanism. Here we have a public key and a private key. So the integrity or the message is coded with the public key and decoded by the private key, which I have already talked about when I have talked about the asymmetric case. Now, the functionality of digital signature as and the Mac method is very much similar. What happened here also? Suppose there is a sender and there is a receiver. Right. The sender wants to send a message M. So what happened? It will send a message M with digital signature. And this digital signature is generated by the private key and the message. Okay. But what is the difference between the Mac and the digital signature? Also, you have seen in case of Mac, it sends the message always tell the tag. In case of digital signature, we send message and the digital signature. But the additional feature of that, right? Additional feature of that, if someone, the third party, I'm talking about the third party, if it know the public key of sender, it will identify or verify that this digital signature is originated by that particular sender. There is a small difference, right? Now, what is the advantage of digital signature? Because we already have Mac, so we might have sending the message as well as the tag, right? So what is the advantage of that? The advantage of that is public verifiability. That means if you have signed, or if a particular sender has sent the data message with the digital signature, it cannot deny the fact that it has not digitally signed that message. Because this, if somehow if a third party has access to the public key of that sender, by the public key of the sender, the third party can verify whether this document or whether this message is digitally signed by that particular sender or not. That is the main advantage. And digital signature can be transferred to anyone, right? While the tag was not transferable. And non-repudiation, that means a signer will never deny the fact that it has signed that particular contract. So this digital signature is very fancy in terms of documents. Like suppose you went for your in your block office or the tehsil office for your documents, like what do you say, like your birth certificate. So now everything is digital. So you'll get your document and it is written that it is digitally signed by someone, right? So you cannot verify that, cannot deny that I have not signed that. Similarly, when they multiple company or make a contract, they offer the digital signature, right? Now, if you have any question on digital signature, please ask, and then we'll proceed. We have any question on digital signature? Okay, I hope there is no question on digital signature. Similarly, we have hash function. So hash is a kind of very similar of digital signature, but it is used to map arbitrary length into the fixed digest. Keyed hash function and unkeyed hash function. I'm not going to much detail because it is not generally suited for IoT communication. Now I'll talk about the security and integrity at the same time. When I was talking about the encryption, so we talks about security, we talks about the encryption. When we talking about the integrity, we talk about the MAC and the digital signature, right? Now suppose we want to apply the security as well as the integrity at the same time, which is essential to us. What we need to do? So what happens? Just see. Suppose let me. Okay. Suppose there is a sender and there is a receiver. So what it does, it sends, initially it was sending message tag pair. So what it does, it sends a ciphertext and a tag. So it has two key, K1 and K2. This receiver is also aware of K1 and K2. So K1 is used to encrypt, K2 is used to generate the tag, right? Now suppose if we generate, like suppose we have a message M, so by using K1 we have generate ciphertext C, we have message M, by using K2 we have generated tag T. So we are sending C and T to this receiver, right? And by receiving C and T, this receiver will be able to verify as well as decode the message. But there is a problem with this technique. The problem is this technique is, if a eavesdropper is there and it continuously monitor that C and T, right? So it will be able to know that if a tag is same, so what are the encryption techniques are there? For a same message tag is same, so if what is the encryption technique it is used, and then therefore the encryption mechanism may be compromised or may be known to the attacker. So to avoid this, what we do is, let us say sender, receiver. So first we do the, it has K1, K2. So first point is do the encryption. So message is there, is C. Then the second point is tag. And tag is generated by C rather than M in the previous case. And then it sends C and T. At the receiver end, what it does, first it will verify C and T, and if verification is succeed, then it will decode. So this is the method one should use to simultaneously encrypting and integrating, securing and integrating your message, right? I hope I don't have any problem up till this now. If I have any if you have any question, you can write it. I hope there is no question. Thank you. So this problem I have already told you. These are the only text. So what happened? Whatever the previous method we have done is having for short length. Now, if we have large length of message, what we will do? So to do to same time to have the security as well as the integrity at the same time, we will use CBC MAC, cipher blockchaining MAC. So in cipher blockchaining, what we do, we take fixed length of the messages and we divide into the different block. Then we do the this block will do the MAC operation, and then it will be XOR to the second block, and so that we will generate a tag, right? Similarly, As I already told you, this is for CVC Mac. Similarly, for the variable length, we will uh, append some of the message which is known to, like suppose uh, we our block is, let us say, here I can say our system is designed to use for, let us say, 28 bits. 28 bits, right? But our message is like 24 bits, right? So in the variable length message, what we do, we length bits or 4 bits, we append it, and then we follow the same procedure to generate a tag. I'm quickly rushing because I'm running out of the time. Okay, up till this now, whatever we have talked is generally suited for our what is the conventional mechanism, right? But as we are aware of that our IoT device has very small computational power as well as the battery power, so it has limitation. Therefore, we need to look for lightweight cryptography, and lightweight cryptography is generally used in IoT devices. So lightweight cryptography is the one of the branch of, or the new branch of focusing encrypting something, like, and which is very much useful for where the devices has limited computational communication and storage capability, because all those things up till now we have done is require a lot of computational power. For example, if you case suppose the case of AES, there you need to perform various operation, substitution, transposition, linear operation, and then if you repeat n number of times, it will goes manifold. So why we need lightweight cryptography? So lightweight cryptography, like suppose this triangle is a very much useful when we try to understand the IoT security. So as here you see, if your device has limited capability, and a small latency, or first I will talk about the limited capability, the security of this device is less or it's compromised. Similarly, if you want to have a small latency, or so therefore we need to have lightweight cryptography. And if you want to increase the security over here, you need to have higher RAM, ROM, and energy. Therefore, you need to do a trade-off for your particular application. Okay. So these are the lightweight cryptography standard which people are. These technologies are not mature. I mean, in fact, they are proposed in I think 2 years back. So if someone wants to have a research topic or the research idea, they can go through these 4 topics and they can have idea. And in fact, frankly telling you, a lot of work is going on these 4 areas: e-stream, Caesar, cryptic, and ISO IEC. These 4 areas are, if you want to do research in security for IoT, these are the 4 areas you need to focus. Okay. Quickly, I'll not go to this random number generator, because okay, one thing, another way is to have to secure that IoT is to have a secure hardware, because you are aware of that side channel attack is most prominent for edge layer, right? Therefore, if you want to have a secure IT platform, you need to have secure hardware. So secure hardware uh, can be achieved by using the physical clonable functions. So at the time of the fabricating that particular device, what we can do, we can use the physical unique physical signature such that it will generate a different response on a, it will generate, like suppose I'll give you the example. Let us say there are two devices and it is you fabricated in using POF. So for response R1, this machine will generate this for input I1, this will generate R1, but this will generate R2. Both are having same devices, but they have been manufactured using PUF. Then we have a strong PUF, weak PUF. One most important factor is intrusion detection system. So intrusion detection system, up till now, we have talked about how to secure our network devices or whole IoT system. But if somehow, if there is an attack, we need to detect, we need to detect that attack. Otherwise, if someone is attacked your network, you will not be able to detect that. So your IoT must be able to have an intrusion detection system. So in general, what we do, we have antivirus software in your laptop which detects these attacks, but it will not be the case for the IoT, right? So to do that, what we do, we do the analysis of power consumption, CPU usage, memory consumption, something like that. We do we need to check and to have the a decide on whether there is an attack or not. Now I'll talk about the security requirement of IoT communications. Okay, let me see how much time I have, and then accordingly I will. Okay, I already suited the time. Okay, quickly I'll go through, no problem. So I'm going to discuss the ZigBee. So this is the protocols of ZigBee we are already aware of, right? So first of the things, we need to have AES with counter and CBC MAC is used, right? Do you aware of the replay attack? So replay attack is like there is sender and receiver. So what happened? Attacker, the let us say, is send a first message. So attacker will save that first message, then it will send the second message. So it will send the second message, and then it will, yes.
I cannot see.
Okay. Sorry. I think I'm really sorry. I have not presented till now. Okay, I'm talking about security of ZigBee. I think it is now, it is visual.
Yes.
Okay. Sorry for the misunderstanding. So here we talk about the replay attack. So what is the replay attack? Suppose we have a receiver, we have a sender, and there is an attacker. So if first message is sent by the sender receiver, I'm really sorry. So first message sent by, it will buffer this message, and then it will send to this, and then the second message it will send, and so what it will do, it will bypass the second message, save the first message, and then after that it will send. So the receiver will interpret that the first message was the second message and the second message was the first message. Therefore, we need to have a byte counter or the frame counter more specifically. Okay. So Zigbee employ two keys. One is the link key and another is the network key. Link key is responsible for unicast transmission, while network key is responsible for broadcast communication. Link key and as well as the network key can be generated by or can be known by three mechanisms: pre-installation, key transport, and key establishment. I think, okay, I'll talk about the attack surfaces. One is the sinkhole attack, which is very common to Zigbee. So what happened? A malicious node joined that network and posed that I am the legal network or the legal node, and it will direct all those data to itself, and it will sync all those data. Therefore, we will not able to send our data to whether if we want to send it. So another type of attack is here is ghost attack. Ghost attack in the Zigbee is a malicious node join the do not need to join that network, but it will drain the Zigbee node energy, and then we will have DOS attack, right? Okay. If we have any question, I think already I have suited the time. If you have any question, please. I think not say. I'm really sorry. That's. If you have any question, please. So what happened for all those things? I'll be giving you one of the paper. I'll be yes, research area of LWC. I'll show you again. That is very much important. I mean, people are now focusing on this research area. Okay, I'll say you try to go or you try to search in the Google, that is e-stream, a small e and then a stream, right? So these are very new technique, e-stream. What I'll do, I'll type on that chat box. These both areas you can explore, right? If you have any question, please. Okay, thank you everyone. With next session we will start at 2:30.